Now we're going to tackle, so you'll keep translating into English what I'm about to say. The advantage of working with a Vroid character is that it has shape keys for creating facial expressions. I'm going to teach you how to use them in real time in your video game project. The first thing we're going to do is set up a visual panel to edit in real time the values of each expression using gamepad inputs, and to be able to select an expression to modify. We're going to create the panel and the tools to manipulate the expressions in real time. The first thing to do is to create a plane, which I will rotate by 90 degrees so that it faces the camera when we are in expression editing mode. The panel will be black in order to make the white text stand out. I don't want any reflections on this panel, so I'll set the roughness to 1 to ensure there are no reflections. I'm creating a new collection for this panel to integrate all the elements of the expression panel. In this expression panel, I'm going to create a second collection that will contain the driver objects, which are objects that will manipulate the values of the expressions we had chosen. In the panel, I'm going to add some text. I'm adjusting my text so that it fits within the panel. I rename it by switching to edit mode by pressing the tab key. This text needs to be a child of my panel, so I press Ctrl+P to parent it to the panel, choosing Keep Transform. This way, when I move my panel, the text moves along with it. The text portion needs to be in the expression panel collection. For now, the expression driver collection is empty, and we will deal with it later. Now I can duplicate my text. And I will name it for each type of expression. Now I'm going to create a circle. I rotate it 90 degrees on the x-axis so that it faces the camera. I switch to edit mode, do an extrude, and then scale it. I do another extrude. And I merge at the center. I'm going to create 3 color slots. I switch to face mode to assign a different color to the second slot than the rest of the button. Now I'm going to start by renaming the color slots while creating the materials. So there will be a white slot, a green slot, and a red slot. Since I don't want any reflections, I set the roughness to 1 for each slot. Later, we'll see how we'll change a material. So by default, the materials will be red. And when it is selected, when an expression is selected, the button will turn green so that it's clear which animation's values we are changing. If further on, I'll add an underscore and then I'll take the name of the animation. So the first one will be an error. The second driver will handle the fun expression. The third button will handle the joy expression. Our fourth button will be the sorrow expression. And the fifth and final button will be the driver for the surprised expression. All these buttons must be contained within the expression driver collection. This will be very important when we create our logic node to select the button to be edited. Because in a logic node, when you define a collection, the objects contained in the collection have identifiers, meaning that the first object in the list will have the identifier 0, the second object will have the identifier 1, the third object will have the identifier 2, the fourth object will have the identifier 3, and the last object will have the identifier 4 because we always start counting from 0 and not from 1. In summary, if a collection contains 5 objects, their enumeration will start at 0 and end at 4. I'm going to select all the objects in my panel and press Ctrl+A to apply the rotation and scale of each of these objects. However, I can't do this for the text, so I will select everything, my buttons, and the panel, and perform this operation since it's not possible to apply a scale and rotation to text. Now it's time to edit our drivers. I select the face of our Vroid character, and then I go to the object data properties. I'm going to select the first expression, angry. You have a value that will determine the change in this expression, going from neutral to fully angry, meaning its maximum value. So I keep it at 0, right click on the value socket and select Add Driver. We have therefore opened the driven property panel, and we will choose the object that will modify the value. So I select driver angry 0, and I choose the transformation type, which will be a rotation on the y-axis. I'm going to select local space under space. I'm going to rotate my panel to see if the driver works properly in local mode. A driver extrapolates a value up to 60 degrees when a rotation is chosen. This means that if we go beyond 60 degrees, it will cause an issue. Therefore, in our logic node, we will need to create rules to ensure that the button cannot rotate beyond 60 degrees. I'm going to assign each driver for each expression in the same way, using the same values. All right, all our buttons are set up, so we can move on to the next step, creating the logic node and adding an expression selector to our panel. To do that, we'll first select the panel, then we'll add a game property, and we'll name this property emotion select. The type of the variable will be an integer, so we will select the integer option for our variable. We will press the I key, which corresponds to a debug function when we want to study the behavior of our variables while the game is running. It's time to create the logic node. We're going to name the logic node FaceExpression Editor. The first thing to know is that when you want to edit an object's rotation, you use set attribute and set local orientation. The values won't be in degrees directly, so we'll need to create a converter from degrees to radians. The first thing to do will be a division. We will divide 180 by pi 3.4. We will output the result of this division to a multiply node. As you can see, we have a gray output, which corresponds to the floating point value. As you can see, the set local orientation node has an input value of the Euler type, meaning it has three axes, X, Y, and Z. We only want to input a value on the Y axis, so we will need to find a node called combine XYZ. You'll notice that it has three types of inputs, X, Y, and Z, and a single vector output. We can go ahead and directly connect the vector output to our set local orientation node, and then connect the output of our equation to the Y input. We can copy this structure and simply change the driver object according to the expression in the logical order from 0 to 4. It's time to be able to choose the expression that we want to edit. So we're going to look for a node in the scene category under collection. Get object? No, not get object. Sorry, it's collection, get object name. No, not that one either. It must be the first one. Hold on, is it get collection? No, still not. Where is that node? So it's get object, and we will need to add an index node. No, I'm sorry. Actually, this logic isn't very useful, so we'll do it differently. What we're going to do is look for the emotion select property of our panel. So we'll go into value, properties, and then get object properties. This node is meant to analyze the state of a property, specifically to determine what value the emotion select is set to. By default, it will be 0, since when the property, commonly referred to as a variable, is created, it is set to 0 by default. We are going to connect it to a math compare node. This node will check whether the value of our variable is equal to the parameter we have set in the equal condition, whether that be 0 or 1 or 2 or 3 or 4. We can therefore connect the result of the math compare to the condition for setting the local orientation. We'll simply change the value it's equal to, and based on our collection, that means if it's equal to 0, the angry driver can be adjusted. If the result is 1, then the fun driver, and so forth for each type of expression. Now we're going to create a map range node to convert a value that we haven't defined yet, but we'll set up later. First, let's create the map range node. The maximum value will be 60 degrees and the minimum value will be 0 degrees. Our input will come from the gamepad's directional pad, which will modify the input value. To explain how the map range works, we have an input value and we have a from min and a from max. This means that if we have a property that goes from 0 to 1, it will be converted into degrees, meaning that the output result will be mapped between 2min and 2max, and the from min and from max values will be the range of the variable that we use as the input. I go back to my panel and create 5 new float type variables, which will default to 0. And each of these variables will be named after the expression. It is these values that will drive our driver. I won't forget to enable the debug mode so that I can see the state of the variables when the simulation is running. I retrieve a get object property for the panel and select the expression that will be converted into degrees. So the values of each type of expression will be translated into degrees using this map range. I connect the output of my map range result to each converter that transforms degrees into radians. Now we need to be able to modify the state of our variables. To do that, we will choose the inputs that will select the expression using the emotion select and the buttons that will increase or decrease the values of each expression. For that, I will use the directional pad and I will choose a tap input and then select the D-pad up and D-pad down to choose an expression. This will manage the selection of the emotion that we want to modify. The up button will add a value of 1 to the integer, and the down button will subtract 1 from the integer. I can copy this structure and then we will choose the D-pad left and D-pad right to increase or decrease the values. This value will be incremented by 0.1. As I mentioned earlier, I want that when an expression is selected, the color of the potentiometer changes to green. By default, they will be red, and depending on which emotion is selected, we will switch the color to green. This way we can see which expression is currently active. When we take a look So we will connect the getObject properties for state and motion to a compare node. If it equals 0, let me find it up there. So if it equals 0 for the first expression, which is angry, we want the color to be green. And here we will add a logic branch node. This node has one input. If it is true, then we want the green material. And if it is false, then we want the red material. And we repeat this process for each of the potentiometers. So we're now facing an issue in that at this stage, we haven't set any rules to create a loop. This means that if I press the D-pad up, down, left, or right buttons, the values can drop below 0 or go above 1, which is a problem. What we want is to create a usage range so that the values cannot go below 0 and cannot exceed 1. To do that, we need to set rules that define the minimum and maximum values for our variables. So we're going to start by creating a loop for the emotion select. This means that when we go beyond the last expression, we return back to the first one. To do this, it's simple. We'll get the current state of the variable by using a get object properties node for the panel and selecting emotion select. Then we'll need to use
Désolé, vous avez atteint la limite quotidienne pour le mode vocal avancé. Vous pouvez maintenant passer en mode standard pour continuer à discuter. Très bien. Quel type de système veux-tu créer? Est-ce lié à UpBge, Blender, un plugin, un gameplay ou autre chose? Dis-moi le contexte et l'objectif. Je suis prêt. D'accord. Donc, tu veux que je traduise en anglais tout ce que tu dis en français, c'est bien ça? Vas-y, je t'écoute. Now, to avoid too much duplication of our modified object properties for each emotion value, we are going to call I was saying we're going to call a variable on the fly, meaning here the blue socket corresponds to a string type. It's a color code system you have, though I haven't mentioned it yet. But red inputs are conditions, yellow inputs are objects, blue inputs are strings, and gray inputs are floating point numbers. And finally, the green inputs are integers. So I'm going to look for a node called value. Value switch list compare est un nœud qui permet de comparer la valeur d'une variable avec une liste d'éléments et de renvoyer une sortie différente selon le cas. Value switch list compare. Explanation of the value switch list compare node. When you open this node, there are several things you need to know. First, you have the switch mode. We're going to select equal, and then the input type. Is it going to be a Boolean? So if it's equal, Désolé, je rencontre. So what we want to output with our value switch list compare is which variable we're going to call. Depending on the value of our loop state, if it's equal to 0, we'll call the variable angry. If it's equal to 1, we'll call the variable. You're welcome. You're welcome. Ready when you are for the next part. So as you can see, the value switch compare node has two inputs for each case. These cases are the switches, so we have case A, B, C, D, E, F, and a default case. The default also has to be a string, since we said our output here is of type string. So by default, we're going to look for the names of our variables, that's in the panel, and we'll simply copy and paste each of those variable names. By default, we want angry as the output. In the end, it's not necessary to set the default value because by default, we'll have the angry value anyway, since we're only going to configure the cases. I'm going to copy, the loop states, compare them with their. And I connect the result of my math.compare that equals the value we're interested in to the first slot. So you see, we have two slots, one for the result and one that lets us switch between values. I can now connect the result to the name of the property I want to modify. And our system is finally complete. I'm going to duplicate my loop system. And I'm just going to change the value, the type of the variable. This time I'm going to thank you for watching this video. So I was saying that I'm just going to modify our loop. So now it's not exactly a loop anymore. It's simply a limiter, meaning that if I go beyond 1, I want to stay at 1, and if I go below 0, I want to stay at 0, using float type. There we go. Everything should work now. We've created a system that allows us to a complete real-time expression system.